Hello friends, in this session we are going to see one of the important topic, that is probability. Now, as we have discussed in the session of permutation and combination, that the questions from PNC might not be there in the any banking exam, but the application of it will definitely be there, because the question from probability, especially the questions, the ball and boxes type of question that they ask in banking exams, we have to have a little knowledge from PNC to solve those questions. And that is why we are seeing that topic first. But probability is an entirely different concept. As a concept wise, we have to first understand what probability actually is. Consider this example. First of all, what is probability? Probability is study of chances. Now, these topics like permutation and combination, probability, they are entire different branches of mathematics. So there are big size books specifically based on these topics. But we don't have to learn everything. We have to just learn the typical type of question that they ask in banking exams. And that is why you have to stick with your preparation level, because these are the topics which are not at all going to be useful in other topics. Only specific type of questions will be asked, and you have to have a specific type of skill set to solve those. So what do you mean by probability? As we saw, study of chances. So if I say, I toss one coin. If I ask you, what is the probability of getting head? So if you know this already, because this topic we have seen in 10th standard, 12th standard somewhere. So if you know answer, you will tell me 1/2. But even if you don't know, I'll change my question to, what are the chances of getting heads? So you will say there are 50% chances that head will show up, 50% chances that tail will show up. Now 50% when you say, this percent sign itself means by 100. So you can say it is 50 upon 100. And that means 51s are 52s are. So basically, probability, when we write in fraction form, it is nothing but the chances. Even if you answer 50% is the probability of getting head, it's again a correct answer. It won't be wrong answer. If you say 0.5 is the probability, that is again a correct answer, because 0.5 means 1/2 means 50%. Everything will be same. But in general, we write probability in terms of fraction like this, because when you toss a coin, there are two possible outcomes. Either head will show up or tail will show up. When you write all the possible outcomes in one place like this, this is called as sample space. So sample space means all the outcomes, or the list of all the possible outcomes. So in our sample space, there are two elements, out of which if you want head, that means our favorable element is 1. So technical definition of probability of an event E is favorable outcomes, cases, ways, number of ways, everything means same. Favorable outcome upon total number of outcomes. And total outcomes basically means the size of sample space. How many elements are there in the sample space? There are 2 elements in the sample space, and out of which our favorable outcome is going to be 1. And that is why the probability is 1/2. And that is the reason that we write probability in fraction form like this, and not in percent form or decimal form. Otherwise, everything means same as I said. So if you can write a sample space like this for any event, like tossing one coin, tossing 2 coins, tossing or throwing dice, picking cards. So if you can write sample spaces at one place, then you don't have to know any other topic, because everything will be in front of your eyes. If you can't write, let's say number of cases are so many that you can't write everything in one place, then only the application of PNC will appear. So that is why my advice to all those who find these type of topic little challenging is to go for the sample space. If you can write everything, all the possible cases, then you don't require to think much. Everything will be in front of your eyes. For example, if I ask you, we toss 2 coins, what is the probability of getting both heads? Heads on both the coins. So can we write sample space for this 2 coins? How many cases will be there, or how many possible cases will be there? If you just realize by PNC, because we have 2 coins, for the first coin we have 2 choices. This is not even PNC. This is fundamental principle of counting. So there are two choices for the first coins, and against 2 here, we have again two choices here, head or tail on the second coin. So we have total 2 into 2, that is 2 raised to the power 2, 4 possible cases. 4 is a small number. We can again write the sample space. The sample space here is going to be H on first coin, H on second coin. H, T, T, H, and T, T. So this is how we can sum up our sample space, which has 4 elements into this. These are these 4 elements. So probability, when you say, you first write the denominator, that is total cases. So total cases are 4, out of which our favorable cases are, you want both the heads. And there is only one case out of 4 which has both the heads. That's why the probability is going to be 1 upon 4. If I ask you what is the probability that one head and one tail, one coin has head upon it, one coin has 10 upon it. So again, the total cases will be 4, out of which this and this will be our favorable cases. So that is why there are 2 favorable cases out of 4. So 1 by 2 will be the probability. If you toss, let's say 3 coins, then how many possible or total cases will be there? 2, 2, 2. Per coins, we have 2 cases because head and tail, head and tail, head and tail. So 2 against 2 against 2, 2 raised to the power 3. There will be 8 possible cases or total cases. 8 is again a small number, relatively small number. You can write the sample space for that. But just make sure that whenever you're writing, write with a proper pattern so that you don't miss any case. So first case, we write all H. Then we introduce 1T. When you introduce 1T, it can be HHT, HTH, or THH. Then you introduce 2 T's, so HTT, THT, and TTH. And lastly, all 3 T's. So there are these 8 possible cases, which we call sample space. And now if they are asking you, what is the probability of getting, say, 2 heads and 1 tail? So you have sample space in front of your eyes. So total cases are going to be 8. And if you want 2 heads and 1 tail, so this, and this, these 3 are going to be our favorable cases. So the probability will be 3 by 8. Sometimes the logic can also prevail. For example, if the question is, what is the probability that number of heads will be greater than number of tails? Even if you can't write the sample space for such kind of question, but if you logically think there are 3 coins, so it cannot happen that heads and tails will be equal in number, because 3 is an odd number. So you can't say that one of the case might have heads and tails equal. That is not going to happen. That means there will be some cases where heads will be greater than tails, and there will be some cases where tails will be greater than heads. So by the law of natural similarity, because the coins are unbiased, so why it will happen that number of heads will be greater than number of tails more number of times than tails greater than heads? Why there will be partiality? Obviously, if you can understand the law of natural similarity, naturally there has to be similarity between half the cases have to be heads greater than tails, half the cases tails have to be greater than heads. So out of total cases, if half the cases have heads greater than tails, that means the probability is going to be half. So this is called as law of natural similarity. So if you, even if some questions you can't write this or you can't understand the question even, but if you think like this, there has to be law of natural similarity. Then you can deduce your answer directly to this guy. Or you can just go through sample space. As you can see, you want the probability where heads are greater than tails. So out of total 8 cases, as you can see, 1, 2, 3, and 4, there are these 4 cases where number of heads are greater than number of tails. So answer is going to be half, as we can see. Sometimes because this, sometimes the question can be something you have, say, 5 coins. Now listen this question, because writing the question will unnecessarily confuse you. So just listen carefully. If you say there are 5 coins, what you do is you take out 1 coin. If it is, or let's say there are 5 balls in a bag. 6 balls. Let's say there are 6 balls. 3 black, 3 white. 3 black, 3 white. You take out one of the ball. If it is black, you replace it with white. And if it is white, you replace it with black. Say you do this process 6 times. 6 times you put the hand into the ball. Hand into the bag. You take out the ball. And if it is a black ball, you replace it with white ball. And if it is a white ball, you replace it with another black ball. You do it 6 times. And after 6 times, when you put the hand 7th time, and if you take out a ball, say the question is, what is the probability that it is a white ball? So now if you try to analyze it, or if you try to solve it by the normal probability method, it is going to be lot of work to do, or it is unthinkable in one way. But if you just understand the law of natural similarity, why there will be a possibility? Because everything you are doing with black or white, because there are similar number of black and similar number of white, 3, 3. So whatever is going to happen with black balls, same thing is going to be happen with white balls. So there is a natural similarity. So 7th time when you put the hand into the bag and take out a ball, probability of it being a white or a black ball is going to be half. Okay. So this also sometimes will be useful apart from the typical probability type of concepts. Okay. But it is about this what we saw right now, sample space. It is about the number of cases which you can write the sample space for. But if say there are 5 coins, now if there are 5 coins, then 2 into 2 into 2 into 2 into 2, there are going to be 32 cases. 32 is no big number. You can't just write sample space. You don't have that much time in exam. And plus making a proper pattern, HHHHH, HHHHT, HHHTT. So it is going to be really, really tricky. So for such question, you have to have the knowledge of PNC. So let's see how to solve these type of questions. So again, we'll consider first the same example. If 3 coins are tossed, what is the probability of 2 heads and 1 tail? So total cases, obviously you can write. Total cases you can write with the help of this 2 into 2 into 2, as we did it here as well. Now you want 2 heads and 1 tails. 1 tail. So how much ever different arrangements you can make with 2H and 1T, like HTH, HHT, THH. So those many different cases will be there. So it is like how many different words can be formed by 2H and 1T. And this is what we saw in the PNC. So if you recall the question, typical question from the PNC, like assassination or Mississippi type of question that we did in PNC, how many ways you arrange the letters of the word Mississippi. So all we did there was you count the number of letters. If there are 11 letters, you write 11 factorial. There are 4 S, so you write 4 factorial. There are 4 I's, so you write 4 factorial. And there are 2 P's, so you write 2 factorial. These many different words can be formed with the letters of the word Mississippi. This is what we did. So Mississippi you have to consider as an example. So whenever we say Mississippi, this question should pop up in your mind. So here also same thing. We have to arrange HHT. So how many ways you can arrange HHT? First, there are 3 letters. So you write 3 factorial. And because there are 2 H's, so you divide it with 2 factorial. And 3 factorial by 2 factorial being 3. There are different 3 words that you can make out of HHT. Right? And that is 3 upon 8. So same is going to be the thing in case of 5 coins. So if you say there are 5 coins are tossed, what is the probability that say 3 heads and 2 tails? So the question is, what is the probability that there will be 3 heads and 2 tails? So total cases we already have calculated 32. Out of this, if you want 3 heads and 2 tails, that means the number of words you can form out of HHH and TT. How many different words can be formed out of HHH TT? There are 5 letters, so you write 5 factorial. There are 3 H, so you divide with 3 factorial, and there are 2 t's, so you divide with 2 factorial. 5 factorial upon 3 factorial into 2 factorial is 5 into 4 into 3 into 2 into 1. 3 factorial is 3 into 2 into 1, and 2 factorial is 2 into 1. So 3 to 1, 3 to 1 goes off. 5 into 4, 20 upon 2 is 10. So that means total 10 words can be formed out of HHHTT. That means there will be 10 cases which will have 3 heads and 2 tails. So the probability is going to be 10 upon 32 or 5 upon 60. So if number of coins have been increased, then you have to use the PNC. Now this is about the coins. Let's see what happens in case of dice. So if you say you throw 1 dice, question is, what is the probability that getting non-prime number? What is the probability that the number shown on face is a non-prime? So sample space writing is easy in case of 1 dice. There can be either 1 or 2 or 3 or 4 or 5 or 6. If you're throwing a dice, pasa, we have only 6 possible outcomes. So the denominator is going to be 6, out of which you want a non-prime number. So this is not a prime number. 1 is not prime nor composite. So this is our favorable case. This is not our favorable case because 2 is a prime number. You want non-prime. 3 is a prime number. 5 is a prime number. 4 is not prime number and 6 is not prime number. That means there are 3 favorable cases out of total 6 cases. So the probability will be 1 by 2. So in case of 1 dice, question is going to be easy because there are only 6 possible cases, and that too very easily you can say 1, 2, 3, 4, 5. What if we are tossing 2 dices? What is the probability that getting sum is equal to 10? What is the probability that getting sum is equal to 10? Now, when you throw 2 dices, the total cases are going to be, because there are 6 outcomes on the first dice, 6 outcomes on second dice, 6 again 6, there are going to be 36 cases. Now, 36 is a huge number to write for, but because throwing 2 dice is a typical type of question, and writing the cases, maybe number of cases are 36 more number, but writing a cases is easy. So it is advisable that you write cases. If you don't understand PNC part of it, you write cases. You can just say 1 on first dice, 1 on second dice, 1 on first dice, 2 on second dice, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So there are these 36 cases which are our sample space. So denominator is going to be 36. Now if you want the sum to be 10, sum can be 10 when 1 die has 4 upon it and second has 6 upon it, or 5, 5, or 6, 4. So as you can see, there are these 3 cases where the sum is going to be 10. So 3 are our favorable cases out of total 36. So the probability will be 3 by 36 or 1 by 12. So as you can see now, diagonal wise, the sums are equal. Like this 1 plus 1 is going to be 2. 1 plus 2, 2 plus 1, the sum is going to be 3. Similarly, this diagonal will have the sum as 4, and so on. The 5, 6, 7, 8, 9, 10, 11, and 12. So if you have sample space like you in front of your eyes, you can solve for any type of question, or you can at least memorize this everything. The sum is 2 in one case. Sum is 3 in 2 cases. Sum is 4 in 3 cases. Sum is 5 in 4 cases. Sum is 6 in 1, 2, 3, 4, 5 cases, and so on. You can just count the number of cases and make a note of it. But if you want to solve without having table in front, you can still solve easily, because total number of cases are 36. If you want the sum to be 10, you can just say if the first dice has 6, You cannot have more than 6. So go for the extreme case. So if the first choice has 6 upon it, second has to have 4. Now reduce this number by 1, it will become 5. Increase this number by 1, it will become 5. So the sum stays 10. Reduce this again by 1, it becomes 4. And increase this. Reduce 1 and increase 1. Okay. So reduce this by 1, it becomes 4. Increase this by 1, it becomes 6. If you reduce further this by 1 and increase this further by 1, it is not possible because 7 can't appear. So that means there are only these 3 cases. So you can go it manually like this as well. Okay, so this is about the sum in case of 2 dice. But if the question asks about, say, the product, what is the probability that the product on 2 numbers is even? Product is an even number. Product is an even number. So when do you have even number? The even number can be when first has even and second has odd, then the product is even. First dice has odd upon it, second dice has even upon it, then also product is even. Odd into even is also even. Even into even is also even. Odd into odd. First dice has odd number, second dice has odd number, then the product is odd. So that means out of 4 possible cases, 3 cases have even upon it. So probability will be 3 upon 4. Or if you now count from the table that we have made, you see, this will have odd, this will have odd, this will have odd. In the first column, these 3 cases will have odd product 1 into 1, 1 into 3, 1 into 5. Second column won't have any odd product because there is already 2 everywhere. And 2 will make the product even anyways. Third column will have this, this, and this as odd. Again, fourth column won't have any odd. In fifth column, this, this, and this will have odd product. And again, sixth column won't have any odd. So out of the total 36 cases, 9 cases will have odd product. So remaining 27 will have even product. So 27 favorable cases out of total 36 cases will make our probability 3 upon 4. So you can go it like this also. And if you have table in front, you can go it like this also. I hope you got this. Now this is about the dices. Now comes the important part, that is the cards or box and balls type of questions. Let's start with the cards. So I hope everyone understand the cards, but if somebody have a little issue, let me tell quickly about the cards. So cards, we have 52 playing cards. Jokers are not involved unless mentioned so. So 52 cards. There are 4 suits: heart, diamond, spades, and clubs. These 2 are red suits. These 2 are black suits. Every suit has 13 cards. 1 to 10, they are called as the number cards because they have numbered written. One, of course, has letter upon it, but we call it as a ace or 1. So they are called as the numbered card. And the remaining 3 cards, Jack, Queen, and King, they are called as the face cards because it has face upon it. So such a way there are 10 and 3, 13 cards per suit. Every suit has those 13 cards. So 13 into 4, there are total 52 cards. So this much information about the cards, it is expected that everybody knows because they won't be explaining, especially in banking exams, they don't explain. It is assumed that you know everybody plays cards and everybody know about these cards. So the question asked sometimes can be, out of 52 well shuffled pack of cards, if you draw one card, what is the probability it being a king? What is the probability that the card is a king? Now, naturally, student might think, and it will be not wrong is either, that because there are total 52 cards, there are 4 kings. So the probability will be 4 by 15 or 1 by 30. It is a correct answer. It is not a wrong answer. But what happens is, every time you're not going to draw 1 card. Sometimes you can draw 2 cards as well, 3 cards as well. So in that case, you can't just think like this. You have to have knowledge of P and C for that. So that is why from the first question upfront, we solve these type of questions with the P and C. So if it is about the one card and you are doing it like this, fine. But if there are multiple cards, say you are drawing 2 cards out of the pack of 52 cards, what is the probability that both king? So, in the denominator, you write the total cases. So out of 52 cards, if you are drawing 2 cards, how many way you can draw 2 cards out of 52 cards? Question in PNC was, how many way you can select 2 items out of 52 different items? So selecting 2 out of 52, you write it as 52C2. You write it as 52C2. So those are going to be our total cases because you are drawing or you are selecting 2 out of 52. So how many way you can take 2 or select 2 out of 52? You write it in form 52C2. But you want both to be king. There are how many kings? There are 4 kings. Favorable cases are you have to select 2 kings out of those 4. If you select 2 out of these 4, that is going to be your favorable case. So selecting 2 out of 4, you write 4C2. That is how you are going to write as a favorable cases. So 4C2 is 4 into 3 upon 2. And it is a short trick. And 52C2 is 52 into 51 upon 2. So 2 gets cancelled. This is 3 is 17 times and 4 is 13 times. So it becomes 1 upon 13 into 17, 221. So the probability for both kings is going to be 1 upon 221. Okay. Say again, out of 52 cards, you are drawing 2 cards. What is the probability that 1 king and 1 queen? What is the probability that 1 king and 1 queen? So if you are drawing 50 out of 52, if you are drawing 2, how many way you can select 2 cards out of 52? Again, 52C2. So denominator is going to be 52C2. But the numerator this time, you want 1 king and 1 queen. So out of 4 kings, you have to select 1. And out of 4 queens, you have to select 1. So out of 4, you have to select 1 means 4C1. And out of 4, if you have to select 1 means 4C1. And the sign in between them is going to be into because you have to select 1 king and 1 queen. So in PNC, we have seen whenever there is an AND factor involved, we use the product rule. We multiply these two. And then 4C1 is 4, 4C1 is 4. 52C2 is 52 into 51 upon 2. The 2 can go up and the answer will be 16 into 2 upon 52 into 51. 4 4s are 4 13s are, and then you can say 8 upon 663. That is going to be the answer. Okay, this is the case when you are drawing multiple cards from the pack of 52 cards. Now, what happens in some exams, in some challenging exams like MBA entrance exam or challenging exams, you can draw the cards one by one or without replacement, with replacement. But in banking exam, that is not the criteria. So in our practice session, we might take 1 or 2 questions like that. But right now, because as I said, that if you try to dwell into the topic, then there are lots of things, lots of different possibilities, lots and lots of different conditions. With the same question, you can make, what is the probability that first is king, second is queen, first is queen, second is queen, number of the king from heart and queen from diamonds. So there are multiple questions can be formed from the same example. If you're drawing 2 cards out of 52, multiple questions can be formed. But if you stick with the basic, even if you do particular type of question that they ask in banking exam, because in banking exam, they don't ask a very difficult or tricky, very in-depth question, they never ask. They ask very superficial question, and that too 1 or 2 questions from this topic. So that is why we stick with the basic. Now the same type of question that they ask in case of bags and balls. So let's say in a bag, there are 4 black balls and 3 red balls in a bag. if you draw one ball out of it, what is the probability that it is a red ball? It is red ball. Again, out of total 4 plus 3, there are 7 balls. Out of 7, if you're drawing one, the total cases are going to be 7C1 because you are selecting 1 out of 7. But if you want red, the favorable cases are going to be, you want that 1 to be out of these 3. That means you have to select 1 out of these 3. So 3C1 is going to be the favorable cases. 3C1 is 3, 7C1 is 7. So the answer here is going to be 3/7. But if you, let's say, draw 2 balls, and if it asks, what is the probability that 1 black and 1 red? So out of 7, this time you are drawing 2 cards or 2 balls. So in the denominator, you write 7C2 because you are taking 2, selecting 2 out of 7. You want 1 black, 1 red. So out of these 4, 1 should appear, and out of these 3, 1 should appear. So 4C1, 1 out of these 4, selecting 1 out of 4 is 4C1, selecting 1 out of 3 is 3C1. This also and this also should happen, and factor is involved, so you do product. 4C1 is 4, 3C1 is 3, 7C2 is 7 into 6 upon 2. That upon 2 will go up, it becomes 12 into 2 upon 7 into 6. So this is 6 is 2 times, it becomes 4/7. The probability becomes 4/7. And max to max, in recent year, it has been observed, and in exams like SBIPO, sometimes the question can be about selection of bags. So sometimes the question is, there are 2 bags. First bag has 5 red and 3 blue balls, and second bag has 4 red and 4 blue balls. You select first one of the bag out of it, and then you select ball. First you select bag out of these 2, and then you select ball. What is the probability that the ball is blue ball? These type of questions very rarely can be asked. So what you do in these type of question is, you make cases. Case 1, that you are selecting this bag. So what is the probability of selecting this bag out of these 2? Because there are 2 bags, you have to select 1 out of it. The probability is going to be 1/2. So with the probability 1/2, you selected this bag. And within this bag, what is the probability that you select blue ball? If you are drawing 1 ball, because you are drawing 1, you can directly say 3/8. So drawing blue ball from this bag, the probability is half probability for selecting this bag and 3/8 probability for drawing blue ball out of it. And case 2, you are drawing this bag. So probability of selecting this bag out of these 2 is going to be half, and selecting blue out of it is going to be 4/. And whenever you make cases like this, you add those, because the cases are always in or with each other. Because either this will happen or this will happen. So the factor involved is or. Or means addition. So you add both the cases. So this is going to be 3/16 and this is going to be 4/16. You add both and the answer is going to be 7/16. So the probability that you are drawing blue ball is going to be 7/16 finally. So this is the maximum level of question you can observe from this kind, balls and bags. Otherwise, the questions will be very, very easy in all the other, including RBI Grade B type of exams. And lastly, we have to see one more type of the question, which are probability based questions. The probability is already provided to you. For example, if I say probability that A pass the exam is 1/3. And if I ask you what is the probability that A will not pass the exam? Now, either A will pass the exam or A will not pass or fail the exam. Nothing else can be happen. It can't be like he's on verge, he's pass also and fail also. It doesn't happen. Either this will happen or this will happen. So that means there are only 2 possible outcomes. Either he will pass or he'll fail. So probability or sum of the probability of all possible outcomes has to be 1. This is the rule. So if he passes, the probability for he passing is 1/3. That means probability is not passing will be 1 minus 1/3. That is 2/3. Because sum of all possible probabilities is 1. It has to be 1. 1 means 100%. So 100% should be the sum of all the possible outcomes, right? And that is why if he is not passing, the probability will be 1 minus 1 by 3, that is 2 by 3. Let's say probability that B passes the exam is 3 by 4. So what is the probability that B fails the exam? It is going to be naturally now 1 minus 3 by 4, that is 1 by 4. So this much information is provided to you. This much we have to calculate for ourselves, because the question sometimes then can be, what is the probability that both pass? What is the probability that both pass? So both pass means this also happens and this also happens. That means the factor involved is and. A passes and B passes. So what is the probability that A passes? It is 1 by 3. And what is the probability that B passes? It is 3 by 4. And the factor involved is and. So you multiply together. So it becomes 1 upon 4. If I ask you what is the probability that A pass but B fails? What is the probability that A pass and B fails? So you say A pass means this should happen. So probability that A pass is 1 by 3. And probability that B fails is 1 by 4. So this happens and this happens. The probability will be 1 by 3 into 1 by 4. That is 1 by 12. If I ask you what is the probability that both fail or both don't pass, that means A also don't pass and B also don't pass, doesn't pass. So the probability that A doesn't pass is 2 by 3. Probability that B doesn't pass is 1 by 4. And the factor involved is and. To multiply these two, it becomes 1 upon 6. If I ask you, what is the probability that at least one pass, at least one of them is passed? So we have seen in this PNC as well, for the statement which has at least one into it, we take the complementary case. So what is the complementary case of at least one pass? Imagine you are a parent and you have two kids, both are gone case, and you praying to God, God, please at least one of them be passed. At least one of them be passed. So what is the complementary case of that? Both fail. You don't want both to be fail. When you say at least one to be passed, you don't want both to be failed. So both fail is our complementary case. So what is the probability that both fail? We already calculated that. It is 1 by 6. So 1 by 6 is the probability that both fail. So there are two possible outcomes. Either both will fail or at least one of them will pass. That means these two are complementary cases. So as I said, sum of probabilities of complementary cases is going to be 1. Like in this case, either A will pass or A will fail. They are called as the complementary cases. So their sum of probabilities have to be 1. Similarly here, either both will fail or at least one of them will pass. In which A pass, B fail also allowed. A pass, B fail also allowed. A fail, B pass also allowed. And both pass also allowed. What is not allowed is both fail. Only this is excluded. We are welcoming all these things. So that means out of all the possible cases, we just don't want this much. That means we have to calculate the rest of the probability. Rest of the probability means 1 minus 1 by 6. That is 5 by 6. So for all such question where at least one is asked, be it PNC, be it probability, be it set theory, every time you are going to take the complementary case of it. At least one pass. So complementary case is no pass. Calculate the probability of no pass and subtract it from 1 to get the at least one. So the answer here is going to be 5 by 6. Okay, so this is all the type that we have covered comprises all the questions. Very rarely will they ask the question apart from that. Very rarely. But even if you understand the basic formula of probability, that probability is the favorable observations or favorable outcomes divided by the total outcomes. Even if you understand the basic formula of probability, you can still solve any question that they ask in exams. The questions level are going to be easy. You don't have to go too in depth with this topic because, as I said, Your target should be cracking the exam and not doing PhD in one particular topic. If you know that this topic is not going to be helpful in other topics, so just stick with the very basic question, the type of the question that they ask frequently, and just move on to the topic that are actually useful, like percentage, average, ratio, the core topic. Okay. Let's see the some of the questions now for the practice. Okay, let us start with this question. Okay, let's see this. An unbiased dice toss, find the probability of getting multiple of 3. So, you know, when a dice is tossed, the possible outcome is 1, 2, 3, 4, 5, or 6. So what is the probability that getting a multiple of 3? So in probability, we first write the denominator, which is total number of cases, out of which the favorable cases are this and this. So there are 2 favorable cases out of 6. That means the probability will be 1 by 3. Let's see one more. Two dice are thrown together. What is the probability that sum of the number of 2 faces is divisible by 4 or 6? Divisible by 4 or 6 means it should be either multiple of 4 or 6. First, let's say the total cases. You know, when 2 dice are thrown, first dice has 6 outcomes and second has 6 outcomes. So 6 by 6, there are total 36 possible outcomes. Out of which you want a number to be multiple of 4. So the sum could be either 4 or 8 or 12. You cannot go beyond 12 because maximum sum is 12. And multiple of 6 means 6 and 12. So 12 is already taken here. Sum is 4 in case of 1 and 3. As I said, you have to keep increasing this number by 1 and decreasing this number by 1. Increase this number by 1, decrease this number by 1. So there are total 3 cases where the sum could be 4. For 8, you have to go with the extreme 6 to decrease this with 1, increase this with 1, decrease this with 1, increase this with 1. 3, 5, 2, 6. That means there are total 5 cases. In case of 12, there is only one case. Both have to be 6. In case of 6, we have 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. Such 5 cases. So that means we have total 3 plus 5, 8 plus 1, 9 plus 5. Total 14 cases out of 36 which are favorable. So the probability will be 7 upon 18. So the answer here is 7 upon 18. Let's see one more. In a box, there are 8 red, 7 blue, 6 green balls. One ball is picked up randomly. What is the probability that it is neither red nor green? So because you are drawing just one ball, so don't have to write in terms of C. You can directly write in the denominator the total number of balls. Those are 21. You don't want the ball to be red or green. That means the ball has to be blue. So there are these 7 balls which are favorable out of 21. So rather than writing it as 7C1 upon 27, you can directly write it like this because only one ball is being drawn. Because 7C1 means 7 and 21C1 means 27. So the answer here is going to be 1 by 3, option number 4. Three coins are tossed, the probability of getting at least one head. So you can solve this by writing the sample space, or you want at least one head means 1 minus the probability of no head. Probability of no head will be, there will be only one case with all 3 tails out of total 8 cases because you are tossing 3 coins. So total there will be 8 possible cases. So 1 by 8 will be the probability of no head, all 3 tails, because there will be only one case of 3 tails, right? So 1 minus 1 by 8, 7 by 8 will be the probability that getting at least one head. So option number 4 will be the answer. There are 5 red, 4 green shoes. If one randomly draws a shoe, what is the probability of getting a red shoe? So again, same thing, because only one is being drawn. So you can directly say there are 5 out of total 9. So 5 red out of total 9. 5 by 9 will be the probability. Let's see one more. Now, A speaks the truth 80% of the time. That means probability that A telling the truth will be 80% means either you can write 80 upon 100 or 4 upon 5. B speaks the truth. That is probability of B telling the truth is 60%, 60 upon 100, or you can write it as 3 upon 5. What is the probability that they tell truth at the same time? That means This also is happening. This also is happening. So factor involved will be and. Probability of A telling a truth is 4/5. B telling a truth is 3/5. Both telling a truth means this also should happen and this also should. That is 12 upon 25 or 48 upon 100. That makes it as 0.48. Option number 2 will be the answer, 0.48. A leap year it is. What is the probability of getting 53 Sundays? So if I ask you any random day, what is the probability that it is a Sunday? I mean, you wake up someday from coma, you don't know what day it is. And if you try to decide, let's find out the probability. What is the probability that it is a Sunday? So, there are total 7 outcomes. 7 days are there. Out of which there is one possible, one favorable case, that is it is a Sunday. So 1/7 will be the probability of having Sunday on any random day. So same thing you have to consider in this question. First, we have to consider how the year goes. So in a leap year, there are 366 days. If you divide it by 7, we get the complete quotient as 52 and the remainder is going to be 2. That means there will be proper 52 weeks of 7 days each and 2 extra days will be there. If there were 364 days, proper 52 weeks will be there. That means every day is going to be appearing 52 times. But because there are 2 extra days, that means whatever the first 2 days are, so 1st January and 2nd January, 7th January, then comes the 8th January to 14th January. This is how the weeks are formed. 15th to 21 and so on. In the last, it is going to end at 29th December and will start from 23 December, the last week, the 52nd week. And then there will be 2 remainder means 2 extra days. So 30 and 31st December, they will appear after this complete 52 weeks are done. So first week, second week, third week, similarly, this is going to be 52nd week. And after the 52nd week is over, there will be 2 more days, 30 December and 31st December. This is how the calendar or the days in this particular year will look like. So every day is appearing 52 times till here. If you want the Sundays to be 53, that means this or this has to be Sunday. If this is a Sunday, then that day also is going to be Sunday because proper 52 weeks will happen. 53rd Sunday will appear on 30th December. Or if this day is Saturday, then this day will be Sunday and then the 31st December will be Sunday. That means 1st January has to be either Sunday or Saturday. So we have 2 favorable cases out of 7. The 1st January has to be either Saturday. Then also there will be 53 Sundays. And if the 1st January is itself Sunday, then also there will be 53 Sundays. So that means we have 2 favorable cases for the 1st January out of 7. So the probability is going to be 2/7 for 53 Sundays. Easy. Let's see one more. A father purchases 3 dresses for his 3 daughters. The dresses are of same color but of different sizes. The dresses are kept in dark room. What is the probability that all 3 will not choose their own dress? So this is the type of the question which you try to solve by PNC or any other method. They start unnecessarily look like very tricky question. Whereas even if you can just write the sample spaces, that means all the possible outcomes, then the question becomes very easy. Consider that the names of the daughters are A, B, and C, the capital A, capital B, and capital C. And the dresses that he bought from them, or the sizes wise, is A is the dress for A, B is the dress for B, and C is the dress for C. Now he keeps all these 3 dresses in the dark room. And the 3 went and picked one dress. So what all the possible outcomes are there? It might happen that A selects A, B selects B, and C selects C. Or A selects A, B selects C, and C selects B. So basically, we are just arranging ABC in different ways. Then ABC done, ACB done. Then BAC and BC. Then CAB and CBA. So it is like arranging 3 people in a row. So there are total 6 possible outcomes, out of which you want what is the probability that not all the 3 not choose their own dress. That means none of the girl picks her own dress. Those are going to be our favorable cases. So is the first case favorable? No, because in this case everybody is picking the own dress. Is the second case our favorable case? No, again, because A is selecting her own dress. No girl should pick her own dress. Is the third case favorable? Yes. A is selecting B, B is selecting A. No, third is again not favorable because C is selecting her own. Is the fourth case favorable? Yes. A selecting B, B selecting C, and C selecting A. So no girl is selecting her own dress. That is a favorable case. Is the fifth favorable? Yes, again. A selecting C, B selecting A, and C selecting B. Is the last one favorable? Again, no, because B is selecting her own dress. So out of total 6 cases, there are 2 favorable cases. That's why the probability will be 1/3, option number 2. So if such a random question comes up, you can still solve by making sample spaces. And that is why you should do practice about sample spaces for different kind of questions. Let's see now some previous year question. What kind of questions have they asked in our exams? So this is the question from RBI Grade B. A bag contains 2 red, 3 green, and 2 blue balls. 2 balls are drawn at random. What is the probability that none of the ball drawn is blue? So there are total 2 plus 3 plus 2, 7 balls. You are drawing 2 balls out of it. So the total cases will be 7C2. You want none ball to be blue. That means the ball should be out of these 5. So any 2 balls you are selecting out of these 5 will make our favorable cases. So how many ways you can select 2 balls out of 5 balls? With 5C2 ways. So favorable cases upon total cases. 5C2 is 5 into 4 upon 2. 7C2 is 7 into 6 upon 2. 2 gets cancelled. That is 20 upon 42 or 10 upon 21. So the probability here is going to be 10 upon 21. Easy. Let's see this. A bag has 7 red, 4 white, and 3 green balls, while another bag has 5 red, 6 yellow, and 3 blue balls. A bag is selected at random and ball is drawn out of it. Find the probability that the ball drawn is red. So as we discussed earlier, we have to solve these type of questions by making cases. Case 1 is we select this bag. So what is the probability of selecting this bag? Half. There are 2 bags. Selecting 1 bag out of 2 is 1/2. And selecting a red ball out of it is number of red. Those are 7 upon total. That is 11 and 3, 14. This is the case 1. Case 2 is selecting this bag. So with the 1/2 probability, we'll select first this bag, and selecting red out of it will be 5 upon 40. This probability here is 7 upon 28. This probability here is 5 upon 28. And as we discussed earlier, when you make cases, you add those because cases are or with each other. So 7/28 plus 5/28, it is 12/28. Dividing by 4, it becomes 3 upon 7. So option here is going to be 3/7. Easy. Okay. Let's see a challenging mains level question. It's not difficult. It's just a little lengthy because it's a mains again. Bag has 15 red, green, and blue. So number of red plus green plus blue, the total number of balls are 15. We are considering there are R number of red, G number of green, and B number of blue balls. Number of each ball is different in the bag. Difference between red and green is same as difference between green and blue. So that means red minus green should be equal to green minus blue. If you solve this, it becomes 2G is equal to R plus blue. So if you replace R plus B with 2G, so 2G plus G, 3G becomes 15 and number of greens become 5. So number of greens are definite that there are 5 number of green balls. Now again it says probability of selecting one blue ball from the bag is greater than 0.5. 0.2. 0.2 means 0.2 means 1 by 5, or because there are 15 balls, you can write it as 3 by 15. So probability of selecting blue if greater than 3 by 15, that means number of blue are greater than 3. So you just have to now see these two conditions, that blue have to be greater than 3 and green being 5, blue cannot be 5 because then each ball is different. Number of each ball is different. So you just have to take care of two things. B cannot be 5 and B has to be greater than 3. So what is the number of blue balls? It cannot be 3 as we just say. It has to be greater than 3. Can it be 4? Yes. Can it be 5? No. Can it be 7? Yes. Can it be 9? Yes. So possible number for blue balls is 4, 7 and 9. That is B, D and E. Option number B. Option number B will be the answer. Easy. Let's see one last question from this topic. This is again a question that they asked in 2016, one of the banking exams. It is little different yet easy. Find the probability that a number from 1 to 300 is divisible by 3 or 7. So if I ask you how many multiples of 3 are there up to say 20. Up to 20, if I ask you how many multiples of 3 are there. So first is 3, then 6, then 9, then 12, then 15, then 18. So 1, 2, 3, 4, 5, 6, 6 multiples. Or you can just say, because every third number is multiple of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Every third number is multiple of 3. So out of 20, because every third number is multiple of 3, if you divide 20 by 3, it is going to be 6 point something. So you can just say there are 6 multiples of 3. You forget whatever comes after point. You just have to consider the complete quotient. So complete quotient being 6, there are 6 multiples of 3 up to 20. So similarly to that, first we have to see how many multiples of 3 up to 300. So you'll do 300 upon 3, that is 100. So there are going to be 100 multiples of 3. Similarly, how many multiples of 7 are there? So to find the multiples of 7, we'll have to divide 300 by 7 and check the complete quotient. 7 4s are 28, 7 2s are 40. So there are 42 multiples of 7. So when you write 3's multiple, there are 3, 6, 9. That number will have, that list will have 21 into it, 42 into it, 63 into it, and different numbers which are multiple of 3. When you write the multiples of 7, it will have 7 into it, 14 into it, 21 into it. Similarly, 42, 63 into it. So if you want to count the number of the numbers which are multiple of 3, those are 100. The numbers which are multiple of 7, those are 42. But these 100 and these 42 will have common numbers, like 21 is common, 42 is common, 63 is common. So that means all the multiples of 21 are going to be common, because 21 is 3 and 7's LCM, or product in this case, because they are co-prime numbers. So we have counted the multiples of 21 two times in this list also and in this list also. So we have to subtract those ones. So how much ever multiples of 21 are there up to 300, we have to subtract them once. So how many multiples of 21 are there up to 300? 21 ones are 21, 90 means 21 fours are. So there are 14 multiples of 21, like 21, 42, 63. So such there will be 14 numbers which we have counted twice in this list also, this list also. So we have to subtract those. So there are 100 multiples of 3, 42 multiples of 7, but 14 numbers which we have counted in this list also, we have to subtract those ones. So that means there are 128 favorable cases out of 300. So the probability is going to be 128 upon 300, or 32 upon 75. Option number B. Option number B will be the answer. Got this? So as you saw, first of all, there will be rarely the questions asked on these topics. In RBI Grade B, not even every year they have asked the questions. In RBI Grade B, there is not even a mains exam. So you can't have like complete set of data interpretation based on probability, because that usually happens in mains exam of banking PO exams. So that is again not going to be the case for you. There will be one odd question in our pre-exam based on this topic. So if you have done some amount of practice and if the question falls within it, you solve it. Otherwise, if the question is unnecessarily tricky, you can afford to leave that question. For that one tricky question, if you are, let's say, spending your 1 or 2 days, especially when the exam is already announced and the number of days we are having are now getting decreased day by day. So spending 1 or 2 entire days on probability like topic, which is not going to be very useful, is not a good idea. Just do whatever questions we have done, just practice those, do the practice sessions, and that should totally be sufficient. And then again, if you're solving a mock, in mocks also, there will be a variety of questions that you can observe. Thank you for watching this video. Bye-bye. Have a good day.